to Ethical Hacking and Penetration Testing, brought to you by Eduonix. This is Chapter 3, Scanning and Vulnerability Assessment. So things that we're going to be covering in this chapter is practical avoidance techniques. So these are the kind of 5 main things that you want to achieve with any penetration test or hack. You want to scan quietly, to fully understand the target, and it has to be quiet because if you are going in there ringing alarm bells, then chances are by the time it comes to actually performing the hack, you'll already be blocked, and the target will be well aware of what you're trying to do. Get in silently. Try not to set off any intrusion detection systems. Try not to crash any systems, or if you do need to crash a system, at least do it once you've completed your goal. You've got the information you require, you've installed a backdoor so you can get in again. After that, you need to cover your tracks, which could be removing logs, etc. Once you've done that, you can exit, hopefully silently again. So now we have a NIDS and a HIDS. So a NIDS is Network Intrusion Detection System, and a HIDS is a Host Intrusion Detection System. So in IDS, we'll look for an unusual amount of packets. Now when I say unusual, it could be compared to the last 10 minutes, it could be compared to the last 10 hours, or even compared to the last day. Anything it deems unusual, it will flag and monitor. It's usually quite configurable, so you can either say just keep watch and report if it's still happening in 5 hours time, or you can say alert me immediately and block any packets if it's an intrusion detection and prevention system. You'll be able to block packets as well. It'll look for any unusual patterns of packets, things that might represent a particular scan. If it's, I don't know, say if an IDS is looking at 4 different network ranges and each one of them is getting pinged at exactly the same time, that would be an unusual pattern. Unusual packets as well. Are there any kind of half packets that are being sent to try and avoid the IDS? Of course, if he sends a bit of a packet and then another bit of a packet, there's a good chance it could be reformed on the other side, past the IDS. Packet anomalies as well. I think that would look at payloads, etc. If there was any actual exploits going on, it should be able to pick them up. And they should both log out alerts via the GUI, email, SMS, anything like that. They should all be fundamental features of a network or host intrusion detection system. So here we have an example of a network intrusion detection system. They're placed at a strategic point or points within the network to monitor traffic to and from all devices on the network. It performs analysis for passing traffic on the entire subnet. It works in promiscuous mode, so it can read all the packets. And it matches the traffic that is passed onto the subnets to the library of known attacks or known exploits. And once the attacks are identified or abnormal behavior is sensed, the alert can be sent to an administrator or moderator. The example of the network intrusion detection system would be installing it on the subnet where firewalls are located in order to see if someone is trying to break into the firewall. Ideally, you would scan all inbound and outbound traffic. However, if you do that, it'll probably create a bottleneck because it'll take so long to do, and it would impair the overall speed of the network. So you need to try and work out that there's a particular triangle which demonstrates this quite well. However, you need usability over performance and security, and it has to be kind of decided. If you're going to be going, whole hog full security, it's going to be slower. You want to be a bit faster and make it a bit less secure. That's a call that has to be made not by yourself, but by either the senior manager within the office, or the business, or somebody high up within the IT department. Now, a host intrusion detection system runs on individual hosts or devices on the network. It monitors the inbound and outbound packets from the device only, and it will alert the user or the administrator of the network if any suspicious activity is detected. It will take a snapshot of the existing system files and match it to a previous snapshot. If the critical system files were modified or deleted, the alert is sent to the administrator to investigate. A good example of HID's usage would be to put it on a mission critical machine which are not expected to change their configurations at all. That would be a terminal in a data center somewhere controlling something, and you didn't want anything inside there to be modified. So this is a really basic example here of statistical anomalies. So it takes a snapshot or a benchmark, and the benchmark looks like 1, 2, 3, 4, 5, 6, 7, 8, 9. It's a very basic, simple example. Data 1 comes through, that's exactly the same. Data 2 comes through, and the fourth packet in is different. It's 9 instead of 4, so it would flag that. And the third packet comes in, and the first one is different. That's a 0, it should be a 1, so that'll get flagged as well. So an IDS which is anomaly based will monitor the network traffic and compare it against an established baseline. The baseline will identify what is normal for that network and what sort of bandwidth is generally used, what protocols are used, what ports and devices generally connect to each other as well. It'll alert an administrator or a user when traffic is detected which is anomalous or significantly different to that of the baseline. The issue is that it may raise false positive alarms for legitimate use of bandwidth if the baselines are not intelligently configured, which is always a worry. So here we have a signature-based IDS, which will monitor packets on the network and compare them against a database of signatures or attributes from known malicious threats. This is similar to the way most antivirus software detects malware. The issue is that there will be a lag between the new threat being discovered in the wild and the signature for detecting that threat being applied to your IDS. During that lag time, your IDS would be unable to detect that particular threat. So noise can severely limit an IDS's effectiveness as well. Bad packets generated from software bugs, corrupt DNS data, and local packets that simply just escaped can create significantly high false alarm rates. It's not uncommon for the number of real attacks to be far below the number of false alarms. The number of real attacks is often so far below the number of false alarms that the real attacks are often missed or ignored because they think that they're false positives as well. Many attacks are geared for specific versions of software that are usually outdated. A constantly changing library of signatures is needed to mitigate the threats. Outdated signature databases can leave the IDS vulnerable to newer strategies. For signature-based IDSs, there will be a lag between a new threat being discovered and the signature being applied to the IDS, as I said. It can't compensate for weak identification and authentication mechanisms for weaknesses in network protocols. When an attacker gains access due to a weak authentication mechanism, then the IDS can't prevent it from any kind of malpractice, purely because it doesn't see it as a threat. Encrypted packets are not processed by intrusion detection systems, therefore any encrypted packets can pretty much flow freely through the IDS. IDS software provides information based on the network addresses that is associated with the IP packets that were sent to the network. That is definitely beneficial if the network address contained the IP address that was accurate. However, if the address is not accurate and could be spoofed or faked, then it's quite pointless. So due to the nature of network intrusion detection systems and the need for them to analyze protocols as they're captured, network intrusion detection systems can be susceptible to the same protocol-based attacks that network hosts could be vulnerable to as well. Invalid data and TCP/IP stack attacks may cause a NID to crash, essentially. So avoiding the IDS. There's a number of techniques that attackers are using. That the following examples I've given here are quite simple measures which can be taken to avoid the IDS. fragmentation. By sending fragmented packets, the attacker will be under the radar and can easily bypass detection systems' ability to detect the attack signature. And avoiding defaults as well. The TCP ports utilized by protocols doesn't always provide an indication to the protocol which is being transported. For example, an IDS may expect to detect a Trojan on port 12345. If an attacker has reconfigured it to use a different port, the IDS may not be able to detect the presence of that particular Trojan. Using any of the HTTP, DNS, HTTPS ports are always a good method. Coordinated low bandwidth attacks. Coordinate the scan among numerous attackers or agents, and allowing different ports or hosts to different attackers makes it difficult for the IDS to correlate and capture packets and deduce that the network is actually under attack or under a scan. So address spoofing and proxying. The attackers can increase the difficulty and the ability of the IDS to determine the source of the attack by using a poorly secured or incorrectly configured proxy server to bounce an attack from. If the source is spoofed and bounced by the server, then it makes it very difficult for the IDS to detect the origin of the attack. Now, finally, we have pattern change evasion. So IDSs generally rely on pattern matching to detect an attack, but by changing the data used in the attack slightly, it might be possible to evade detection. For example, an IMAP server may be vulnerable to a buffer overflow, and an IDS is able to detect the attack signature under 10 common attack tools, but by modifying the payload sent by the tool so that it doesn't resemble the data that the IDS is expecting, it may be possible to evade it completely. So you can also attack via a proxy, as I said. An example program you can use is called SocksChain. The program can use SOCKS version 405 or HTTP. It does have SSL support as well. Proxying will create a virtual channel through proxies, or in this case, many proxies. And disabling audit files and disable auditing. The first thing an intruder will probably do after gaining admin privileges is to disable auditing. NT Resource Kit's auditpool.exe is a tool that can be used to disable auditing on the command line pretty much instantly. At the end of this day, the intruder will just turn on the auto auditing program again, and the admin will be none the wiser. There's a number of reasons why auditing is important. These include successful attacks often are preceded by a series of unsuccessful ones. Detecting an attack in its early phase can contain the damage. Recovery often depends on realistic damage and target assessment. Auditing and intrusion detection helps determine many casual factors about people and systems that you're going to be attacking. Assessing the network compromise is dependent on auditing as well. One of the main goals of auditing is to identify the actions taken by the attacker on the network, so you know what to repair. Without it, you're pretty much fighting blind. So you would clear the event logs. An intruder can easily wipe the logs in the event viewer. Event viewer on the attacker's host can open, read and clear logs of the remote machine as well. The process will clear the logs of all records, but will leave one record stating that the event log has been cleared by an attacker. The event logger service controls whether events are tracked on Windows 2000 systems. When this service is started, user actions and system resource usage events with the following event logs can be tracked, and there's only really one, to be honest. There's application logs logged by applications. Application log records logged by applications. Now, there's a great hacking tool called WinZapper. Is a tool that an attacker can use to erase event records selectively from the security log on Windows 2000. To use the program, the attacker runs winzapper.exe and marks the event records to be deleted. You then press delete events and exit, and there you go, it's disappeared. So to sum everything up, after the attacker has gained access to the system, you can't simply trust the security log. It's considered that the event logs are generally not compromised without shutting the service down by legitimate means. So WinZapper is a tool that's capable of editing it without shutting it down via Windows. Now, Evidence Eliminator is an easy to use and very powerful tool It contains very flexible data cleansing systems for Windows PCs. I believe there's also a version out there for Linux as well. Daily usage protects you from unwanted data being permanently hidden in your PC. It cleans the recycle bin, internet cache, system files, temp folders. Evidence Eliminator is good at getting rid of things like website cookies, stored documents, even things that have been put on there maliciously like Trojans. It'll find it and it'll clean it. So there's some practical avoidance techniques. Obviously these are only implemented by black hats. It's definitely a good idea to do it if you are testing a system, because when it comes to delivering your results, it would be far better if the people you're delivering the results to were none the wiser that anything actually happened. They'd be expecting you to say, well, I couldn't get in, it was a successful attack on your behalf because you're very secure. Unlike them saying, well, I managed to get in with your user account, this is what I could see, this is the information that I stole, and this is how I got out silently without you knowing.